This question wants you to plot the quadratic graph. So you need to complete the table of values in order to get the coordinates to plot them on. So for the first one, -1, if you put that into your calculator, you may get -1 squared as -1, but you should be able to use your own knowledge of multiplication of negative numbers to know that -1 times by -1 is going to be 1. -5 times by -1 will be +5. And then add 3 as well. So 1 add 5 is 6, add the 3 actually gives you a 9. It's quite common to see a 7 there because you've got your -1 times -1 as -1 instead of 9. 2 squared is 4, take away 10 is -6, add 3 is -3. And then 4 squared is 16, take away 5 times 4, which is 20. So 16 take away 20 is -4, and then add 3 is -1. So once you've got your table of values, you want to actually plot that onto the axes. So at -1, you've got a value of 9. At 0 is a value of 3. 1 is a value of -1. 2 is -3. 3 is -3 also. 4 is -1. And 5 is 3. And then you just want to draw a line. Don't do it with a ruler, you want to try and make a smooth curve through them. The next part says find estimates for the solutions of the equations. And if you remember, the solutions to the equations are where the curve crosses the x-axis. So we've got somewhere around 0.7, and we've also got somewhere around 4.3. So if you've got somewhere, the mark scheme will usually be within a range of values, or just using your curve. So it crosses at 0.7 or 4.3. Question 2 is just a straight, it's asking you to complete the square. So straight complete the square question. X squared minus 8x plus 21. So I need to halve the coefficient of my x minus 4 squared. 4 squared would be 16. We want 21. So you need to add 5 on the end, which means that my value of a there, the equivalent part of it there is 4. And note, it's because there's already a minus there, a is 4, not -4. B is 5, the number added on to the end. This leads into the second question because it wants to know where our minimum point is, our turning point. Remember, the turning point, you use the square to actually determine where it is. So we want to find out where this bracket is 0, because that is the lowest that we can actually get. That bracket is 0 when x is equal to 4. And what is the value of y when x is equal to 4? 4 take away 4 is 0. 0 squared is 0. Add on 5. So the value will be 5. So that coordinate there, of the bottom point, is 5. So this one wants you to sketch that graph. It tells you what the function is. It wants you to sketch that graph. And this is actually quite a tricky one, because the first thing that you should do is complete the square to find out where the turning point is. So completing the square on that, you get x minus 2.5 squared if we halve that. So we want to square 2.5, which is 6.25. So you need to add on 3.75. So you should be able to work out where the turning point is actually going to be. And the turning point is going to be at 2.5 for the x coordinate and 3.75 for the y coordinate. So what we actually get there is a situation where the turning point, because it's just a positive x squared, the turning point is above the x-axis and it's never actually going to cross the x-axis, so you can't factorize or find a solution for that. So the only other thing you can state, you'd normally want to state the x-intercepts, but there isn't any. The y-intercept is when x is equal to 0. When x is equal to 0, that will disappear. that will disappear, and you'll just be left with 10. So the y-intercept is at 10. So you can then sketch that, because you know that the y-intercept is 10, so put that point on, and the turning point is when x is 2.5 and y is 3.75. So we've got that general shape and those specific points that it touches. So we then need to recall some information from graph transformations in order to be able to answer that. That's why this is such a high grade question. So the graph transformation is that we're having 2 added on inside the brackets of the function, which actually means that we will move left 2. So if we add on 2 inside the function, then we move left 2. If we take away 3 outside the function, then we're going to be moving down 3. So determine whether our original function, moved left and 2 and down 3, has any real roots. We want to see if we move that left 2 and down 3, will it have any real roots? Well, if we move it left 2, then the turning point would be at 0.5. If we move it down 3, it would be at 0.5. So turning point at 0.5 if we take away 2, and 0.75 in this case. So we're still actually above the x-axis, and therefore it won't cross the x-axis, so no real roots. No real root, as the turning point is still above the x-axis. For the last question, you want to plot on some lines so that you can describe that region that satisfies x is less than 3, y is more than minus 3, and y is more than 2x. So the first line you can put on there is x is less than 3. So I want to plot the line x equals 3, but it can't be equal to, so I have to do a dotted line. Now I know that x is less than 3 on the left hand side of that, so I'm going to get rid of the right hand side. I want y is greater than minus 3, so I want to draw the line y is equal to minus 3. It can't be equal to minus 3, so I'm going to put a dotted line. Y is greater than minus 3 above that line, so I'm going to get rid of everything below the line. Now for the line y equals 2x, you do need to use the gradient and intercept. The intercept is going to be at 0. The gradient is going to be 2. So for every 1 along, I'm going to go 2 up. 1 along and 2 up. It can't be equal to, so I'm going to draw a dotted line. And we want the bit that is greater than 2x, so I'm going to get rid of the bit below. So therefore, that is my region that is left there.